Everyone look down here. We're going to look at these. I'm not going to make you write these down. You're welcome. But we are going to talk about definition of inequality. For any real number, A and B, A is greater than B if and only if there is a positive number C such that A equals B plus C. Can you guys scoot this up, please? A little more. A little more. That way it doesn't, okay. Now, that's just definition of one thing being bigger than the other. Down here, comparison property, if A is less than B, or either A is equal to B or either A is greater than B. Those are the three possibilities of when you're comparing two numbers. You see you have the transitive property, which works if A is less than B and B is less than C, then A has to be less than C as well. Okay, same thing with greater than, okay? The addition property works, subtraction property works, okay? Now, the main thing we're going to deal with today is this. I'm going to draw an angle. I'm going to make this about the same distance every time. Now, look at this side right here. Pins. That's not going to work. I'm going to have to use pen. You guys see that better? Turn one of those lights off too. Joe? Very good. Now, as you can see, I want to look at the length of this side. What I'm going to do is I'm going to keep this the same. I'm going to make this angle, am I making it bigger or smaller right now? When I draw that line right there, I'm making that angle a little bit bigger, aren't I? What we're going to do is look at what happens to this line, this dotted line I keep drawing. And I'm going to make it bigger again, keeping it same length. I think it's pretty obvious here. Okay, this was my first angle, here to here, correct? And this is my dotted line. What happened when I made the angle just a little bit bigger? What happened to the dotted side? If you were to describe to me what happened to it. It got bigger, didn't it? Now, guess I'll use purple here. Then I drew it again. What happened to the dotted side now? Got even bigger, didn't it? Then you've got the last one, which I didn't quite connect the dots perfectly. Whichever way, what happened, it's the biggest one, isn't it? If you think of these as arms, what would you say? It's holding this angle, is it not?
Yes.
As the arms grow, as the angle of the arms gets bigger, what happens to the side it's holding? It gets what? Bigger. Would everyone agree with that? Now, that concept I want to apply to this. Let's say I made this A, B, and C. I told you this was 90 degrees, this was 60 degrees, and this was 30 degrees. List the sides from greatest to smallest. I said list the sides. That's the vertex. And that's the angles. I want you to list the sides. Are sides angles? What is each of those sides? What are they called? A segment. So you have to list 3 segments. Guys, we've got to be better at being able to label these correctly, like we talked about earlier, which probably will be the first thing we take a test on when we come back second semester. Will be a simply labeling test. See if you can label things properly. What do you guys think? What is the largest side? So I would say AC, and then I would put a segment above it, correct? What is the next largest side? What is the next largest size? Huh? I'd bet money that most of you did not do that the way that I wanted you to do it. So I'm gonna draw another triangle, and it's okay. I'm kind of setting you up here, but that's all right. We're gonna draw a second one. Say this is X, this is Y, and this is Z. This angle is 59. This angle, 61 degrees. And this angle is 60 degrees. List these sides from greatest to smallest. Why is the one I just gave you harder? Huh? They look like they should be equal? But we can't go by how it looks, right? We got to go by the information given to us. Think back to my little different colored drawing up there. What was the point you think I was making here? Okay, you've got 2 arms here, and this is an angle, right? When I made the angle a little bigger, what happened to the arms, the side it was holding? As this angle got bigger, what happened to the sides it was holding? Got bigger. So on and so on. Or you could say the side contained in that if you don't want you think it's a kiddie way to say it. That's 2 arms holding it. This angle contains this side. Okay, and as it gets bigger, what happens to the side opposite it? It gets bigger. Now, use that concept and answer my question down there. Tell me what's the biggest side, then the next smallest, and then the next smallest. What do you think of the biggest side is? Nope. Once again, what did I say up here? The bigger the angle, the bigger the side it's holding, correct? Use that concept down here. And by the way, you guys told me the smallest side. You can't go by how it looks. What did I say? The side contained by the largest angle has to be the what? Largest side. Because isn't that what happened here? As this got a little bigger, the side opposite it. I mean, isn't this a triangle? Isn't this a triangle? Isn't this a triangle? And isn't this a triangle? You'll learn it better if I can let you see it for yourselves. What happened to this third side here of this triangle as this angle got bigger? It got what? So the bigger the angle, the bigger the third side, right? So look at this again. The largest side is XZ. What is the next largest side? Either way, YX. And what is the smallest side? YZ. Now, let's look at why that is again. What did I say? The largest angle is going to hold the what? Largest side. What's the largest angle? Angle what? Well, how would I name that? Angle, what is this called? Angle what? Angle Y is the largest. It's equal to 61 degrees. Okay? What is the side that it's holding, that it contains? The one opposite it, right? So that would be X to what? This has to be the biggest. What's the next smallest angle? Angle. Angle Z. And it is 60 degrees. What side is it holding? XY or YX, either or. What is the smallest angle? Angle. So it has to be, opposite it has to be the what? Smallest side. Now, does that work out on what we did up here? What's the largest angle of these three? Opposite it should be the what? Biggest side. Was that true? Obviously. It's obvious here because the angles are different. It wasn't obvious here because the angles are really, really close to each other, aren't they? What's the next largest angle? 60 degrees. What's it? What's the side opposite it? B to C. So it's the next one, right? And then the smallest side, A to B. So you see how that works. Now, they may ask you to list some of these from greatest to smallest or what? Smallest to greatest. You're going to use the angles. Now,
And will they have us name that way, like angle Y equals 61? Is that
if they want you to list the sides, that's how you have to list sides. Now, what did I do different here? Two things. I asked you to list the what? Angles from smallest to greatest. Now, what did I give you up here? Angles, and I asked you to list the what? Sides. Here I gave you the length of the sides, and I'm going to ask you to list the what? Does the concept change here any? It's just we're going backwards, right? So what's going to be the biggest angle? It's a small. We could think biggest or smallest, however you want to think about it. Which one's going to be the smallest angle? E. Why? Because it's holding the smallest what? Side. So our smallest is angle E, and you have to write it exactly like that. Okay? Well, what is the next smallest? Angle D. Why? Because 9 is the next smallest what? Side. So angle D. And what is the largest angle then? because it holds the largest what? Side. Do you see how this is kind of a simple concept that kind of can be made kind of difficult if you just go by what you see? They may purposely try to trick you on this assignment and give you something like this one and then label the angles incorrect or not draw it to scale, in other words, okay? So what do I want you paying attention to? How it looks or the information given? The information, the measures, things like that, okay? Any questions on that? That is the bulk of what this section is about, is understanding that. Kind of the way triangles work. You gotta be kidding me. Other thing, we talk about the exterior angle theorem. What do you think an exterior angle has to be? Well, doesn't necessarily have to be obtuse, but it has to be greater than, what is the exterior angle always equal to? You remember this? Angle 1 here is an exterior angle, right? It's got to be greater than, it's got to be bigger than what? Its two what? Remote interior angles, because the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3, right? Isn't that what it says? Because this plus this equals 180. Well, this plus these two also has this, so this has to be what's left out of 180. Remember that from the exterior angle theorem? So, we know that measure of angle 1 has to be bigger than what? Measure of angle 2, measure of angle 3, or measure of angle 4, or the measure of angle 5, or the measure of angle 7, and the measure of angle 8. Can't include 6 because it's not a remote exterior angle to this one. But see, for this triangle, it would be greater than all of those. Does that make sense? And so on and so on. So you have to remember that on some of your problems. Guess what they're doing here? They're asking you to list the angles and sides of each triangle in order from smallest to greatest. So they're going to ask you to list both of them, which you should be able to do. What are they asking you to do here? They didn't give you a third angle. How can you find it?
180.
Add it up, subtract from 180, correct? I think you guys can do all that. They might give you some where these sides are the same. If the sides are the same, what do you know about the angles? They're the same, right? In any triangle. Okay? A lot of different types of problems. I would like to get you guys started on this, because there's not, like I said, there's not a whole lot to this except for that. Like I said, the assignment is long, but the nice thing is you have, looks like what? What time is it right now? You have 37 minutes today and 50 minutes tomorrow. Numbers 1 through 6, 8 through 19, 22 through 37. It's about 30 problems. Write problems, draw figures, show all steps, and work. There won't be, I think, but 2 problems where there are some equations. You guys will probably need help with one of those tomorrow. Okay? I will probably do one of them on the board. So how much do you think that one that I didn't do on the board is probably going to be worth? You don't do that one, you probably, best you can get on it's about a 7 or an 8 out of 10. Especially when all these are really just one answer questions, right? Probably an 8 out of 10, to be honest. But I think you can do it. Okay? Don't go overboard. Remember, you don't have to write the directions, those in bold. Just draw the figure, okay? And when there's one figure for 10 problems, draw one nice big figure for that one. Don't draw it over and over again, okay? And I know I'm probably not supposed to say this, but when you're using ones like that, use a pencil, not a pen, and very lightly mark on the ones on your book once for a couple of problems and erase it, and then mark on your paper a couple of times and erase it for those that have about 10 problems to go with them. A lot of times it helps to label the figure. Okay.
Yeah, that's for tomorrow. I did 3 and 7.
All right, let's get to work.